Hello, my dear students. If you can solve this question, please try it and check for the answer at the end of the video, or else you follow this video, you'll get the complete clarity how that products are forming and what is the name of the product. You will get the complete clarity on the concept. Okay, so here if you want to solve this question, first what is this reaction, you should have an idea. That is acid catalyzed hydration. So this is acid catalyzed hydration reaction. So how many concepts are involving? Majorly here two concepts are involving. Concept number one, Markovnikov rule, and concept number two, ring expansion. So one by one steps clearly we check here. First I am taking here step 1. See, in the step 1, Markovnikov rule, we have to talk about Markovnikov rule. In the given reactant, here Markovnikov rule, what is meant by Markovnikov rule? Stable carbocation formation takes place. In the Markovnikov's rule, what's happening here? Stable carbocation. So stable carbocation formation takes place where? See, two double bond, two carbons are there. Just imagine this is carbon A and carbon B. In which carbon here forms stable carbocation? You people all know very well, if positive charge present on the carbon B, that is more stable carbocation. So that's what simply we can write here. What here, according to the Markovnikov rule, we are getting a carbocation. Which degree carbocation here? Second degree carbocation. It is a second degree carbocation. If positive charge present on the first A carbon, it is first degree. So first degree more stable or second degree more stable? Second degree carbocation is more stable. That's what we got, second degree carbocation, by following the Markovnikov rule. Very good. So now coming to the next one. The main story starts from here. What is that main story here? You see here, ring expansion. Step 2, we have to talk about ring expansion. What is ring expansion? Ring will be expanded. That means 4-membered ring will be converted into 5-membered ring, or if they give 5-membered ring, it will convert it into 6-membered ring. Okay, ring expansion. Why this ring expansion is possible? What is the reason behind the ring expansion? The small rings bond, what is that? Angles. Angle strain is more. That's why here they can't exist with that angle. That's what they enhance that angle of the ring. That's why 4-membered ring will become 5-membered. 5-membered ring will become 6-membered. Only these two generally possible in the conditions. So here, when this ring expansion is possible, when the ring is attached with positive charged carbon, that means carbocation. So adjacent carbon is positive charged carbon atom, then ring will be expanded. So now we have to focus more on this concept, ring expansion. So if you take, I am taking that reactant where that second degree carbocation which is formed. Just focus here. I am giving numbering here. This is first carbon. Just you take it like that. 2, 3, 4, 5. The point here we need to focus is the bond between the second carbon and the fifth carbon break down. And this fifth carbon will go and attach with the first carbon. So in this process, the positive charge which is present on the first carbon will disappear, and the second carbon, due to bond breakage, here you see this unequal break, here positive charge and here negative charge. This negative charge will go and attack on the first carbon. How that ring is producing, just you focus here. So then the ring will be converted into 5-membered ring. Have you got it? Where is the positive charge? Here is the positive charge. This is first carbon, second, third, fourth, and fifth. So ring is expanded from 4-membered to 5-membered. Is it clear? Because adjacent carbocation is there. That's what this ring expansion is possible. Right. Without cation or positive charged carbon atom, ring expansion not possible. So now here you see that step number 3. After ring expansion, hydride shift takes place. Here on the second carbon, positive charge is there. It is a second degree carbocation. Here also it is existing as like a second degree carbocation. But when compared to the second degree, third degree is more stable. That's what here what is happening in this case, what is happening simply here the hydride shift takes place. Here each corner having hydrogen, that hydride shift takes place to the second carbon. You see this right now. Here we are taking that 5-membered ring. We are taking that 5-membered ring. If you take that 5-membered ring, the positive charge which is present on the second carbon, okay, is shifted to first carbon. Shifted to first carbon. Okay, why? Here this hydrogen, generally here hydrogen is there. This hydrogen is moving to here. This positive charge is coming to here. Therefore, here what happened? It became as like a third degree carbocation. It became as like third degree carbocation. So after that, you see this step 4. If you come to the step 4, what's happening? Here, what is our reaction name? Acid catalyzed hydration. Okay, right? Acid catalyzed followed by hydration. So last step is hydration. Hydration means the 5-membered ring which is formed here, the 5-membered ring which is formed, see this, and it is having positive charge here. It's treated with water, where the water contains OH minus, it will attack on this positive charge. So here you see this, if it is attacking on the positive charge, we are getting this product. So can you name this product here simply? We can say that 1, 2, 3, 4, 5. Okay, so we can write that product name 1-methyl, 1-cyclopentanol, 1-cyclopentanol. Have you got it? So this is our product name.